This lecture we will discuss some MCQs of chemical reaction engineering. So first one is 2a plus 4b give us 4c plus 5b. From the previous equation A, this is an equation. If this equation is elementary, then if this is elementary reaction, then the rate of disappearance of A will be given by Ka, rate constant on the basis of A, concentration of A to the power 2, concentration of B to the power 4, or it can be or A is equal to KCA to the power 4 and CB to the power 2, none of them. If this reaction is elementary, then the rate of disappearance of A will be given by minus RA is equal to KACA to the power 2, stoichiometric coefficient of A, CB to the power 4, which is stoichiometric coefficient of B. If the rate law from the above equation come out from an experiment to be, suppose this is an equation, and from this equation, if we perform some experiment and we obtain the rate law from experiment, which is minus RAK ACA to the power 1 over 1.5 CB to the power 3. Note this, from elementary reaction or from elementary reaction, the rate of disappearance of A is this one. But if we perform some experiment and we obtain the rate law for RA, then this reaction would be elementary, non-elementary, both. So for elementary reaction, the rate of disappearance of A will be this one, and if we perform some experiment and we obtain the rate law in this form, then this reaction will not elementary reaction. So it will be elementary reaction, non-elementary. So it will be non-elementary because the rate law is not corresponding to the stoichiometric coefficient. When there is no direct correspondence between the stoichiometry and rate, then such type of reaction will be called. When there is no correspondence between, like this, there is no correspondence between the stoichiometry of A is 2, but here 1.5, stoichiometry of B is 4, but here is 3, here is 4, here is 3. So if there is no direct correspondence between the stoichiometry and the rate, then such type of reaction will be called dash, as in MCQs number 51. So this one or this one. So if there is no direct correspondence between the stoichiometry and rate, then such type of reaction will be elementary, both, addition, non-elementary. It will be non-elementary. Which of the following is series reaction? A is converted into B and B is converted into C. A is converting into B and A is converting into C. A is converted into B and C is converted into D. So which one is series reaction? This one is. In series reaction, reactant first form the intermediate, and after the intermediate, and then the intermediate form the product. So this one is the series reaction. Which is the parallel reaction? A is converted into B and A is converted into C at the same time. This is competitive reaction. A is converted into B, C is converted into B, A converted to B, B converted into C, C is converting into B, D and D is converted to D. This is series reaction, and this is the complex reaction, and this one is the parallel reaction. So this one is the parallel reaction. All of the above, this is wrong. So A is the correct option. Molecularity is the number of molecules reacting together, total mole molecule of the reaction, molecules of the product, total molecule of the product, or all. So molecularity is the number of molecule of reacting component in the reaction. So it is the number of molecule of reactant in the elementary reaction. So molecularity is the number of reacting molecule in the elementary reaction. It is not the molecule of product or total number of molecule. A is converted into B. The molecularity of this reaction is 1, 2, 3, 0. So the reacting molecule is 1. So molecularity is 1, not 2, 3 or 0. A plus B gives us C plus D. Molecularity of this reaction is, if this reaction is elementary reaction, then the molecularity of this reaction will be 1 plus 1, 2. The number of reacting molecule in the elementary reaction is called molecularity. So there are two reacting molecule in the elementary reaction. So molecularity is 2, not 3, 4, and this is the wrong. 3, 4, and none are the wrong. So the rate of reaction is usually determined from lab experiment, theory, law of mass, section, all of them. So rate of reaction is usually determined from the lab experiment, determined from the experimental observation. So molecularity of a reaction can be number like 1, 2, 3. It can be 1 point fraction like 1.2, 1.3, 1.4, and so on. It can be one number only, it can be prime number only. So molecularity is a number like 1, 2, 3, 4. So it is a number. Order of reaction can occur in whole number. Order of reaction can be 1, 2, 3, 0, which is whole number. It is a natural number. Yes, 1, 2, 3, 4. It's a natural number. It can be in fraction form like 1.2, 0.5 order, 1, 3, 0.33 order. Order of reaction can occur in whole number. Yes, it can occur in fraction. Yes, 0.5 order can also occur. Natural number. Yes, because every whole number is a natural number. All of them. So all of them is the correct option. This one is the correct option. K is the rate constant is equal to K naught E to the power minus E by RT, where E is called the frequency factor, the collision factor. Both A and B are pre-exponential factor. So it is a pre-exponential factor. It is also called the frequency factor. It is also called the collision factor. So both A and B are the correct option. We take molecularity for direct reaction only. We can take the molecularity of elementary reaction, non-elementary, addition, none of them. So we can take the molecularity of elementary reaction only. So we can determine the molecularity of elementary reaction, and we can determine the molecularity of rate determined step. Each reaction has only one step. Elementary, non-elementary. Elementary reaction has only one step. The reaction mechanism is the step-by-step sequence of elementary reaction, step-by-step sequence of non-elementary reactions, the step-by-step sequence of addition reaction, the step-by-step sequence of elimination reaction. So reaction mechanism is a step-by-step sequence of elementary reaction. So when many elementary reaction combine, it gives us the mechanism of reaction. So it is the sequence of step-by-step sequence of elementary reactions. So when many elementary reaction combine, it gives us the mechanism of the reaction. So mechanism of reaction consists of 2 or 3 elementary reactions. R is converted, reactant is converted into product, which is correct mechanism of this reaction. What is the correct mechanism for this reaction? This reaction cannot occur in one step, it can occur in many steps. So A reactant is converted into P. This is the mechanism of this reaction? No. P is converted into R. This is the mechanism of this reaction. R this reaction? No. P is first converted into the intermediate or radical. The radical then disappear and it gives us the B radical. The B radical then disappear and gives us the product P. The product then gives us the product P. So then gives us the reactant A. So here product is converted into the reactant, but here the reaction is from reactant to product. So reactant is first converted into the intermediate B, and then A intermediate is converted into the P. So first of all, the P is converted into A intermediate converted into B. So this is like this. R is converted into intermediate A converted to B converted into P. So this is product. So this is the correct mechanism, which consists of step by step sequence of elementary reaction. So this is the elementary reaction, this is the elementary, and this is the elementary reaction. So this 3 elementary reaction Elementary reaction give us the mechanism of the reaction, mechanism of this reaction. The slowest step in chemical reaction determine the dash of reaction. The slowest step in chemical reaction determine the dash, the rate, molecularity, order, none. So the slowest step is the rate determined step of a chemical reaction. The slowest step is the rate determined step of a chemical reaction. This is very important. This one is the correct option. A is converted into B. So this reaction occur in two steps. This reaction occur in two elementary steps. The first one, in first one step, A is converted into the radical C, and in the second step the radical C is disappearing and converted into B. The first step occur in 10 seconds while the second step occur in the 1 minute. Which step determine the rate of the above reaction? Which step? There is one step and this is the second step. So which step determine the rate of this reaction? So this step will determine the rate of this reaction because this is the slowest step. This occur in 1 minute and this occur in 10 seconds. So 1 minute is larger than 10 seconds. So this is the rate determined step of this reaction. So the second step determine the rate of this elementary reaction. The unit of rate constant for zero order reaction whose rate law is minus Ra is equal to K Ca to the power 0. This will be equal to 1. K is equal to rate, and rate is nothing but mole per unit volume into per unit time. Mole per unit volume is nothing but molarity, and this is the time. This is mole per cubic meter cube into second, and this is the mole per meter cube is nothing but molarity, or mole per liter is molarity. So this is the molarity into time. This is also cubic meter. This is the time, and here is the second, which is again time. All of the above are the unit of rate constant for the zero order reaction. Minus Ra is equal to Kca to the power n. The n is the order of reaction. The unit of rate constant for n order reaction is, so it will be equal to K is equal to the unit of rate is mole per cubic meter into second, and this will come down to the denominator, which is mole per meter cube into the power n, which is equal to K. Yes, mole per meter cube into n. This n will come to the numerator. This will be minus n, will become minus, and this is 1 over second. 1 divided by second is equal to K. Yes, this is also correct. So the unit of rate constant, this is also correct. The unit of rate constant is also, this one is also correct. So mole per meter cube, so air mole per meter cube, this is 1 minus n, 1 minus n into 1 over second. Yes, this is also the unit of rate constant for an order reaction. Mole per meter cube is nothing but molarity. Yes, this is molarity into 1 over time. Yes, this is also the unit of rate constant. All of the above are the unit of, this one is the correct answer. The unit of rate constant for second order reaction is, so this is the general for n order reaction. If for second order reaction, this n will become 2. So again it will be 1 minus 2 minus 1, 1 divided by molarity into time, 1 divided by molarity into time. The unit of rate constant for the second order reaction in 1 divided by molarity into time. Now what is molarity? Mole per meter cube into second, and time and second. Yes, this is also correct. This one is also correct. Both A and B. Yes, both A and B are the correct unit of rate constant for the second order reaction. The rate constant K for the first order reaction is, so for first order reaction n will become equal to 1. So 1 minus 1, 0, n into the power 0 is 1, 1 divided by time. So 1 divided by time, 1 divided by second square, 1 second cube. So this one will be the correct answer for the rate constant unit. This is the unit of rate constant for the first order reaction. Atom or group of atom on which unpaired electron is present is known as atom, element, radical, molecule. So atom or group of atom, suppose this is CH3, this is group of atom on which electron is present. This is the radical. Suppose this is atom on which one electron is present. So this is radical. These are the radical. Atom are group of atom on which unpair on which one electron is present and known as the radical. Yes, this is the radical. Calcium ion is called cation or anion. So first of all, cation is positive charge. This is the cation and this is the anion. So Ca plus 2 is positive charge, so it is the cation, and this is one is the anion. So Cl minus is the anion, and Na, for example, Na is the cation. Chain reaction occur mostly in three steps, which are initiation, propagation, termination, propagation, elimination, chlorination, termination, carbonation, and oxidation. So chain reaction occur in three steps, which are the first step is initiation reaction, the second is propagation, and the third one is the termination. So a dash, a double dash option is the correct answer. So this was about the chain reaction. So this is all about the MCQs of chemical reaction. So thank you very much for your attention.